Hey guys, today we are going to solve this problem of Codeforces round 993 div 4 problem E, insane problem. Okay, so let's read the problem first. Wave is given 5 integers k, L1, R1, L2, R2, and Wave wants you to help her count the number of ordered pairs x, y such that all of the following uh, are satisfied. So x is from L1 R1, y is from L2 R2, and there exists a non-negative integer n such that y by x is equals to k to the power n. So first of all we have t as test cases, then we have 5 integers k, L1 R1, L2 R2, and for each test case we have to output the number of matching ordered pairs x, y. Okay, so let me just explain you this problem by the help of this one particular test case 3, 5, 7, 15 and 63. Okay, let's see. So I am taking this test case. It's basically 3, 5, 7, 15 and 63. So this is your k, this is your L1, this is your R1, this is your L2, this is your R2, right? So it is said that x ranges from L1 to R1, both inclusive. Your y ranges from L2 to R2, right? Okay, L2 to R2. And you have to count all the ordered pairs which satisfy this condition that y by x is equals to k to the power n, and k has been given to you, right? This is the problem. And the constraints are, let's see the constraints. What are the constraints? K can be from 2 to 10 to the power 9, and L1 R1 can be 10 to the power 9 as well, from 1 to 10 to the power 9. Okay, so these are the constraints that is also we'll need to keep in mind, right? Okay, so how can we solve this problem? Like, what should be the first thought that should come in our mind for solving this problem? Let's see what we can do here, right? Okay, so we have to find out these, we have to count the x, y ordered pairs which satisfy this condition, right? Now we can conclude one thing, that k is an integer, right? And it has been said in the question that n is a non-negative integer, right? If I'm not wrong, it's said that there is a non-negative integer n, so it can be 0 or it can be any natural number, right? That is what it is. So if k is an integer, right, n is also an integer, so obviously k to the power n will always be an integer, right? This is the first thought that we should think of, right? The first thing that we should think of. Similarly, we can say that y by x, this should basically produce an integer, right? Okay, now let me just write here y by x equals to k to the power n. Okay, now if I ask you what is the maximum possible value of k to the power n, what is the maximum possible value of k to the power n? So it's very simple, right? K to the power n is equals to y by x, so maximize y and minimize x. That will give you the maximum value of k to the power n. What will be the minimum value of k to the power n? It's simple, minimize y and maximize x. That will give you the minimum value of k to the power n. What is the maximum, or what can be the maximum value of y? Obviously R2. And what can be the minimum value of x? L1. What can be the minimum value of y? L2. What can be the maximum value of x? R1. So I can say one thing, that my R2 by L1 will be less than or equals to k to the power n, will be less than or equals to L2 by okay, I'm sorry, I did opposite. My L2 by R1 is less than or equals to k to the power n is less than or equals to what? R2 by L1, right? Yes, R2 by L1, right? So this is the first thing that I have concluded. Now I need to find some kind of algorithm that can just iterate through this range, right? And then I can simply check ordered pairs x, y which satisfy the condition, this particular condition, right? This base condition. I can find those pairs. So what can be the maximum size of this range? Like, what can be the worst case? of this range. Let's find out, right? Okay. So I can say that like if I have to you know minimize this. Let's suppose I want to minimize this term and I have to maximize this term for the worst case. So I can say take L2 as minimum and R1 as maximum. Similarly, take R2 here as maximum and L1 as minimum, right? Okay. So my L2 can be as minimum as 1 and my R1 can be as maximum as 10 to the power 9. And similarly, my R2 can be as max as 10 to the power 9 and my L1 can be as minimum as 1. So this can be, in the worst case, it can go till 10 to the power 9 because we can consider this to be as 0, right? Approximately 0. So we can say that this thing, the value of k to the power n, can be as high as 10 to the power 9, right? It should not go beyond this. This is the first conclusion that we can make. Okay. Now if I say that in the worst case k to the power n is 10 to the power 9, so if I take log base k, so I can say log of 10 to the power 9 base k, and this comes out to be n. So log of 10 to the power 9 to the base k, this can be the maximum value of n. So we can do one thing. What we can do is we can iterate from 0, 1, 2. Likewise, we can go till log of a particular number to the base k. And this particular number can be, in the worst case, 10 to the power 9. So basically the loop that we were thinking of, this particular loop, right, this particular range that we were thinking of, this can be, in the worst case, log of 10 to the power 9 to the base k. That's it. So it's fairly within the time limit and it will not cause any problem. And if we can say that what can be the minimum value of k, that is 2. So in the worst case, the loop can be of log of 10 to the power 9 to the base 2 order, right? And this is approximately somewhere 29, 30 somewhere, right? So this is a fairly a small loop. That will not cause any error, right? So okay, we have concluded one thing, that we can iterate from the maximum to the minimum to the maximum value of k to the power n, and this loop can be as long as 29 to 30 iterations. That's it, not more than that, right? Okay, so that is the first observation that we made. Now let's see how can we solve this for each value of n. Like we have k, so how can we solve it for when n is 0, when n is 1, when n is 2, like, right? So let's see how we can do that. So let's just take the example again. We have k as, in this particular example, right? This, I'm talking about this thing. Okay, this is it, right? So I can just copy and paste it here. Okay, and let's just see how we can do that. Okay, let's see. So I took k to the power n and I said that the minimum value can be the minimum value we have seen, it can be L2 by R1, right? So L2 by R1, 15 by 7, and the maximum value can be R2 by L1. So R2 is 63 and L1 is 5, right? Okay, so if you find these values, let's see what these values come out to be. So 15 by 7, it will be 2 point something, right? 2.14 something. And my 63 by 5 will be 12.6. Okay, let's take log base k, and also one more thing, it's k here is 3, right? So I can just replace 3 here. I can say 3 and 3. So let's take log base 3 of these numbers. So log base 3, 2.14, and it will obviously be n log base 3, 12.6, right? Okay, so let me just calculate these values. It is log base 3, 2.14. Okay, so it comes out to be 0.69 something, and my 12.6 to the base 3 comes out to be 2.30 something, and we have to take n as an integer only, that is basically non-negative integer. So the first non-negative integer greater than 0.6 is obviously 0, then it will be 1, then it will be 2, because 2 is still less than this. Can we take 3? No. So that simply means that my n will range from 0 to 2, right? So this is the first thing that I have concluded. Okay, fine. Now let's calculate k to the power n. What is my k? My k is 3, so 3 to the power 0, 3 to the power 1, and 3 to the power 2. So this comes out to be 1, this comes out to be 3, and this comes out to be 9. So I have just 3 cases, so I can just simply deal with these 3 cases. Okay, let's see. I have also been given that my x ranges from 5 to 7 and my y ranges from 15 to 63, right? Okay. Now what I'm saying is, I'm saying that my y by x is equals to k to the power n, and first value of k to the power n is 1. So I'll put here a 1, right? Okay. Now, if I take the minimum value of x here, or let me just put it in this way. Okay, it's better to put here in this way. Let's suppose I am putting here okay, let me just do it like this: y by 1 equals to x, right? What can be the maximum possible value of x? It will be y max by 1. Similarly, what can be the minimum possible value of x? It will be y min by 1. So what will be y max? Y max is 63. So 63 by 1 is 63. And what can be the minimum value of y? It can be 15, right? I have put the ranges right? Yes, okay, it's correct, fine. So y min can be 15, so 15 by 1 is what? 15 only, right? This is 63 and this is 15. So this means that when k to the power n equals to 1, then my possible values of x can be from 15 to 63. But what is the range given to me? What is the range given to me for x? It is just 5 to 7, right? So I cannot take any value. Okay, I'm sorry, it's not right to draw it like this. My x can range from 5 to 7. My possible values are this, but my x is actually here. So I cannot take any value, any of these values I cannot take, because x is bounded within this interval, right? So here my answer will be simply 0. Okay, so that's it. So let me just see if I'm going right or not. 63 and 5. Okay, fine, I think I'm going right. Okay, so we cannot take any values, right, for this, for x. Okay, one thing that I think I messed up. Okay, okay, I'm sorry, I made a mistake here. 0 should not come here, right? Fine, 0 should not come here, this should not come here. Okay, this is not in my range. Okay, fine, I'm sorry, I made a mistake, right? Just excuse me for this. Okay, so let me just erase it up, everything. Although the base idea remains the same, but obviously we cannot take this value because it is not here. So I can just erase this up, this and this and this. Fine, these are the possible values of n. Only 1 and 2, not 0. Okay, I made a mistake. Okay, fine. So let's talk about this value of k to the power n when it is equals to 3. Okay, so I can say that my y by x is equals to 3, or I can say my x equals to y by 3. So my x max can be equals to y max by 3, and my x min can be equals to y min by 3. What is y max? 63 by 3, it's 21. And what is y min? It is 15. 15 by 3 is equals to 5. Good. So the possible range that I got is from 5 to 21, right? X can take any value from 5 to 21 for this to get satisfied. Y by x to be 3. X can take any of these values. Okay, but what is the real range of x for me? It is 5 to 7, right? So that simply means that I cannot take all these values. I just can take 5, I can take 7, and I can take 6. So how many values did I get here? 3, right? So I can say that I have 3 ordered pairs x comma y which satisfy this condition 3 to the power 1, right? Similarly, we can do for n equals to 2. Let's see. N equals to 2. So 3 to the power 2, k to the power n equals to 3 to the power 2, that is equals to 9. So y by x equals to 9. This implies x equals to y by 9, and my x max can be y max by 9, and my x min can be y min by 9. My x max is 63 by 9, that is 7, and my y min is 15 by 9, that is somewhere 1 point something, right? 1 point. Okay, doesn't matter, right? Okay, so that simply means that my x, the possible range of x can be from 2, it can be from 2, and it can go till 7, right? But what is the real range of x for me? It is from 5 to 7, 5, 6, and 7. So I can take 5, I can take 6, I can take 7. But these values 3 and 4, I cannot take them because they are to the left of the range of minimum possible value of x. So I cannot take these values. So I'll have to take these 3 values only. So for this as well, I got 3. For n equals to 2, I got 3 ordered pairs x comma y. So what will be my final answer? My final answer will be equals to 3 plus 3, that is equals to 6. So this is the simple logic of this code, and I'll show you. This is the possible answer also, right? 6. This is it, right? Fine. So what is the conclusion? What is the final solution of the problem? It's very simple. First of all, what I'll do is I'll find the maximum and the minimum possible values of k to the power n, and then I can do a loop of n which will range from log of minimum value to the base k, and it will the loop of n will start from log of minimum possible value to the base k and log of maximum possible value to the base k, right? And what can be the minimum and minimum and maximum possible values of k to the power n? L2 by R1 and R2 by L1. This is the minimum possible value, and this is the maximum possible value. And we have proved this, that this can be as long as, in the worst case, it can be 29 to 30 iterations. So that is fairly within the time limit, right, according to the constraints. And for each particular iteration, I can find out the maximum and minimum possible value of x, and I can compare it within the with the range of x that I have with me, and I can take the intersection of these two and I'll output it as the answer, right? So what can be the different cases? There can be like a few cases. I can just discuss them. It's very easy to understand, right? Let's suppose I have these cases. Okay, let's discuss some cases. So there can be one thing that, let's suppose the possible value of x is this, but my x is ranging from this to this. So in this particular case, my answer will be 0 ordered pairs, right? Similarly, let's suppose the possible values of x can be from here to here, but my x ranges from here to here, that is, it is more than the possible values. Again, for this case, I'll have my answer as 0. Then there can be that the x range is within the possible values. So here my answer will be simply what? It's L1 R1, right? So R1 minus L1 plus 1, right? And it can be like this as well, that few of the x values are within the possible values and few are beyond this. So we'll have to take these values. then it can be the case that few values are within the range and few values are below the range, so we'll take this, right, the common region. So this was very easy, the implementation is very easy, and the code as well is very easy. I'll show you the code here now. Right, this is the code. So first of all, I have my integers L1 R1 L2 R2, and since I'm calculating log and I'm calculating the the value of n, so I'm taking it in long double. Okay, so it's basically I'm inputting first of all k L1 R1 L2 R2, and then I'm calculating the minimum possible value of n and the maximum possible value of n in these variables low and high. And I have just put a check here that if my low is less than 0, then just make it 0, otherwise keep it as it is, because in the question itself it has been said that n is a non-negative integer, so it can be 0 1 2 3 and so on, right? So just I have put this check here, and yeah, so I iterated from low to high value. So these are the values of n. Okay, and it's an important thing that my iteration, this loop, is for the values of n. And then I calculated k to the power n. Okay, and I have used here ceil function. You might have seen that here that I'm using ceil function with power function, because power function sometimes it gives or it returns inaccurate values because it has some kind of approximation algorithm. So for some numbers it outputs wrong results, so it's better to use the ceil function with this power function. So then I calculated the x minimum and x maximum, like I showed you in my here explanation, right? Y max by 3, this will be the x max, and y min by 3, this will be x min. What is this 3? K to the power n. So that is what I have implemented here. And then I have checked that if my x max if my x ka range is less than or more than the possible values, then I do not have any ordered pairs, so I'll just continue. I'll not add anything to my answer. Otherwise I have done just this thing, right? This is just basically dealing with these cases, the possible cases, either this one or this one, right? Suppose this is the answer, so what I'm doing is take the maximum of x, that is this, and take the minimum of x, that is this. Similarly here I can say take the maximum of x, that is this, and take the minimum of x, that is this. That is what I have said. Simply I will show you this: minimum of x max or r1 minus maximum of x min or l1 and plus 1, right? This is very simple. Actually it looks complicated, but it's simple. And then at last I just printed out the answer, right? This is a simple code for this, so I can just run this code and show you the results. Yeah, these are the results, right? And it matches with the correct answers as well. Fine. So what is the time complexity of this code? Very simple. It is basically log of 10 to the power 9 to the base 2. This is the worst case time complexity. So the entire algorithm is just in logarithmic time complexity, and it's it's a good thing, right? It's a very easy problem, and it's very easy to understand as well, right? So yeah, that's it. Meet you in the next video. Thanks.